everyone, in this video we're going to look at radians and then arc length and the area of a sector. So a radian is another way of measuring angles. So just like with temperature, we have degrees Celsius and degrees Fahrenheit, or you can measure things in meters and centimeters or feet and inches. Radians is just another way of measuring an angle. Now, one radian is found when on a circle the distance between 2 points equals the radius. And if you actually measured that angle, you'd find that 1 radian is approximately 57.3 degrees. Majority of the time we can measure radians in terms of pi. Not always, but a lot of the time you will find that we will do that. So 360 degrees actually equals 2 pi, which means 180 degrees would be half of that, which would just be pi. 90 degrees is half of 180, so pi on 2. 60 degrees would be pi on 3, 45 degrees, pi on 4, and 30 degrees, pi on 6. As it said, it's not always done in terms of pi, it's not possible. So you could still have like 2.54 radians, that is fine. And you'll find your graphics calculator doesn't give you answers in terms of pi, it does give you a decimal. If you have one of the small green Texas calculators, that will give your solution in terms of pi. Now, quick and easy to convert between degrees and radians. To go from degrees to radians, you've got to times your degrees by pi and then divide by 180. And if you're going from radians to degrees, times your radians by 180 and then divide by pi. So arc length and area of a sector. So for a sector with radius r and angle theta given in radians, your arc length is length equals theta times r, or the angle times r, and the area is a half times by the angle times by r squared. Now, big point here is that these formulas only work for radian angles. If you have degrees, you need to convert it to your radians and then use the formula. Example 1, a sector has radius 12 centimeters and angle 3 radians. Find its arc length. So the length equals the angle times r, which would be the angle's 3 radians, so it's just 3 times by 12, which is 36 centimeters. So the arc length is 36 centimeters. Now the area equals a half times by theta, which is 3, multiplied by r squared, which would be 12 squared. Calculate this, and you'll get an answer of 216 centimeters squared. Next example. A sector has radius 8.2 and an arc length of 12.3. Find its angle and then we want to find its area. So if we know the arc length is 12.3, it will be 12.3 equals the angle multiplied by the radius. So it'll be theta times 8.2. Just rearrange that and we'll find that theta equals 1.5 radians. Now radians doesn't really have a unit. You'll sometimes see like a little C, sometimes you might see a little R at the top corner like that. But you can just leave your answer with no units. That's fine. Now if we want to find the area, then we just use that area formula. So area equals half times by theta times by r squared, which is half, multiplied by our angle, which is 1.5, multiplied by 8.2 squared. And we'll get an answer of 50.4 centimeters squared, and that's the 3 significant figures. And finally, example 3, the diagram shows a sector of a circle with radius 8 centimeters and an angle of 0.7 radians. For the shaded region, this bit in blue, find the perimeter of that and the area. So to find the perimeter, part A, we need to find the length of the arc, this bit here, and then we also need to find this length, the straight length here, which is a part of the triangle. So first of all, we'll find the arc length because that's the easy one. So the arc length, let's call that A. So A will equal r times theta, which is the radius, which is 8, times by 0.7. So the arc length is 5.6. Now, if this 8 is the radius, it actually also means that this length here from O to B is also 8 centimeters. And now we have two sides in the included angle, which means we can use the cosine rule to find, we'll call that B, that side of the triangle there. So B squared would equal 8 squared plus 8 squared minus 2 times 8 cos of 0.7. So that means B squared would equal 30.1002 and square root that, so B would equal 5.4864. Now we've got that, we can then work out our perimeter by adding A and B together. So the perimeter would equal 5.6 plus 5.4864, which gives us an answer of 11.1 to 3 significant figures. Now part B, we want to find the area of that shaded region, which means we need to find the area of the sector, which is this whole bit here. And then we need to find the area of the triangle, and then we can minus them from each other and we'd only be left with the blue shaded region. So just do that under the picture. So part B, area of the sector first. So we put area of S equals 1/2 times the radius squared times the angle, which is 22.4. Then the area of the triangle, we use the sine rule, so we'll have 1/2 times A times B, and then this angle in between them, which is 0.7. And that will give an answer of 20.615. And so then our area of the sector, so the area of the little blue shaded region will be those taken away from each other. So 22.4 minus 20.615, which gives us 1.79 centimeters squared for our area.